Hello guys and happy Thursday. Today we were working on lesson 15, session 2 in class. So this is the homework for that lesson. Today we more so focused on how to solve our area problems with our multiplication problems. So we're just going to go ahead and jump right on into it because it is kind of a lengthy homework. We have 9 problems. So we're going to get started so I don't hold you too long. So we're going to start with number 1. Number 1 says, what is the area of the rectangle? Write an equation. So over here they drew a rectangle, and then we have our length, which is 7 units, and length could be the top number or the bottom number. It doesn't matter because they're going to be the same size. Okay, and the width is going to be either side of our shape is how wide it is, and that is 6 units. And the length is how long our shape is. So let's go ahead, and I put my labels on there because you know Ms. Newman loves a label. If you label things ahead of time, it helps you when you have to go ahead and do the equations like this one. So this one has the length times the width equals area. So if the length times the width equals area, all I have to do is take my labels that I already put here and put the numbers where they belong. So if the length is here, I go here and see my length was 7 units. So we're going to put 7 units. And I made sure today that I told the kids when we are dealing with measurement, you have to make sure you write your units. Sometimes they may give us centimeters, sometimes they may give us inches, but in the case they do not give us centimeters or inches, they will always give you units. So let's go ahead and finish this problem. So the width is 6 units, so 6 goes here. And because our kids have been practicing that multiplication, we should know our facts by now, so we can go ahead and answer this. 7 times 6 would give me an answer of 42 square units. Okay. And let me apologize just ahead of time about my voice. It's been going in and out for the last 2 days. I don't know if it's just been talking a little too much, or maybe I'm hoping I'm not coming down with something. I don't think I am. Maybe just might be a little, my voice might be a little tired. Okay, so let's go ahead and go to number 2. So number 2 says a rectangle has a length of 8 inches and a width of 7 inches. So I'm going to circle my important information. I tell my kids to do that so that they know what's important, and underline the question. So the question is, what is the area of the rectangle? So let's figure out what the area of this rectangle is. So first thing we're going to do, I tell my kids to do a drawing, because when you draw things out, you get to, you see it clear. Over here they did a drawing, and it was easier for us to understand what they were asking us to do. So they asked me to do a rectangle, so I'm going to draw a rectangle. So they said the length was 8 inches, and remember the length is either the top number or the bottom number, so you can place your number on either side, it doesn't matter. So I'm going to put it at the bottom. So I'm going to write 8 and make sure I put my unit of inches. And then on the sides, I'm going to do my width. The width is 7 inches. So now I'm trying to figure out the area of this rectangle. Remember, area is trying to figure out how many squares we can fit inside of that rectangle. That's why when we find the answer for area, we always put square like they put here in our answer, because that tells us how many squares we can put in there. That'll tell us how many centimeter squares or how many inch squares that we can fit inside of that particular rectangle. Okay guys, I apologize. Our video kind of got stopped, but we're going to go ahead and keep rolling. So we're picking up where we left off at. We're going to go ahead and write the equation for this. So remember, we're doing length times width equals area. So the length is 8 inches, and make sure you write your units. So 8 inches times my width, which is 6 units. I'm sorry, I'm looking at the wrong thing. 7 inches, guys, 7 inches. Miss Newman was looking at the wrong problem. It's okay. Sometimes we make mistakes, but we just keep moving. So now all we do is multiply this, and again, we've been practicing that multiplication, so we should know that like this now. So 8 times 7 would give me the answer of 56, and because this is area, and we're trying to figure out how many squares I can fit inside that shape, I'm going to use the word square, and my unit is inches, so square inches. Okay. And that would be the answer, 56 square inches. Okay, let's go ahead and go to number 3. Number 3 says a square has sides that are 4 centimeters long. What is the area? Write an equation. Okay, that's fine. We can do that. That's no problem. So I want you to notice there's something special about this one, something a little bit different. So for this one and this one, we were dealing with rectangles. One thing we need to know about our shapes, rectangles do not have sides that are all the same. The top and the bottom are going to be the same size. That's why I told you you can put your length either at the top or the bottom. It didn't matter because it's the same size. And the sides, which is the width, those are the same size. So it doesn't matter where you put your number on that. You can put it on the left side or you can put it on the right side. But when it comes to a square is special. A square is special because all 4 sides are the same. They're the same size. So that's why you might be like, well, Ms. Newman, they only gave me one number. I can't do anything with one number. I can't make it a multiplication equation. It's okay. Think about it. So they tell us that a square has sides that are 4 centimeters long. I'm going to circle that important information. And they want to know what is the area. Okay, so let's draw a square because you know Ms. Newman likes to draw our pictures. The pictures helps us to see it better. Ms. Newman gonna do the square as best as she can. I'm kind of eyeballing it, so be kind. All right, so if this is 4 centimeters long, long usually means length. So I'm gonna put it at the top. This is 4 centimeters, okay? Now, I use cm as a shortened version of writing the longer word of centimeters. Now, because with squares, all the sides are the same size, that means if the top is 4 centimeters, guess what? The bottom is 4 centimeters. Guess what? The left side is 4 centimeters. Guess what? The right side is 4 centimeters. So all sides are 4 centimeters because that's the special thing about squares. All sides are going to be the same number. So that's why they only gave you one number, because you only need one with a square. So if the length is 4 centimeters, because the square is special, the width is going to be 4 centimeters. Now we have our 2 numbers. We can go ahead and write our equation and we can solve this problem. So again, we're doing length times width equals area. So the length is 4 centimeters, and make sure you go ahead and write those units. So 4 centimeters times the width, which is another 4 centimeters. Okay, and then when you multiply that, 4 times 4, that is going to give me 16. And because this is area, we have to use our special word of square and our unit of centimeters. So the area of this square is 16 square centimeters. And that is it for the first page. We're going to go ahead and jump over to the second part, which is on the back side of this sheet. So Ms. Newman is going to have to erase this, guys, and move on to the next part, which is page 324. Okay. Okay, so we're going to do numbers 4 through 5, and then Ms. Newman is going to erase and do the rest of the problem 7 through 9, because I have to move the board up. So let's look at number 4. Number number 4 says, write an equation to find the area of rectangle A. This is rectangle A, has the letter A on the inside. So it says, then write the area. Okay, so we can do that, that's no problem. So remember, if we're writing the equation for this and we're solving for area, that equation, if you have trouble and you don't remember what it is, just flip over back to page 323 and you would see that that equation again follows length times width equals area. That is the equations where the equation that we're going to be following to help us write our equations. So, okay, I'm looking for the length. Now let's label, because you know Ms. Newman loves a label. So the length is going to be 3 units. The width is going to be 9 units. So if I'm looking for my length first, I'm going to put 3 units times the width, which is going to be 9 units. Okay, and once I do that, we just go ahead and multiply to get our area. So 3 times 9 is going to give me an answer of 27. And because this is area, we're going to use our special word of square. And then they didn't give us centimeters or inches, but they did give us units. So we write units. Now, it asks us for the area. We're just going to rewrite our answer of 27 square units right here. So this is going to be 27 square units. Okay, and that's it for number 4. So let's go ahead and go to number 5. So number 5 says a rectangle has a length of 6 centimeters and a width of 5 centimeters. What is the area of the rectangle? Show your work. Okay, so let's circle our important information, our numbers, which is the length of 6 centimeters and a width of 5 centimeters. And then we're going to underline that important question of what is the area of that rectangle, because that's what we're trying to find out. So let's go ahead and find that out. Now, you know, Ms. Newman, it says show your work. We're going to show our work with a great picture. So we're going to draw that rectangle. All right, so this is my rectangle, and we're going to start out with our length. So the length is 6 centimeters, and remember the length, we can put that number either on the top or the bottom of our rectangle. It doesn't matter because both of them are the same size. So I'm going to put it on the top, 6 centimeters. And I'm going to use the shortened, abbreviated version of centimeters. Instead of the long word, I'm going to shorten it to cm. Okay, let's go ahead and do the width. The width is 5 centimeters, and remember that can either go on the left side or the right side. It doesn't matter because those are going to be the same size. And I know you might be looking at that rectangle because Ms. Newman is looking at that rectangle right now. She's like, oh girl, you did not draw that the same size. So just charge it to my head and not my heart. I tried my best to draw it the same size, but you get the idea. So this is 5 centimeters, or this could be 5 centimeters. You can put it on either side. So I'm going to put it here, 5 centimeters. And now what we're trying to figure out is the area. We're trying to figure out how many squares I can fit inside of this rectangle. So we can do that by writing the equation. The equation is going to be our multiplication equation. Remember that it's going to be our length times our width equals our area. We're going to follow that. So let's go with our length. So the length they gave us was 6 centimeters. So I'm going to do 6 centimeters and making sure I use my units times my width, which is 5 centimeters. And now all I have to do is multiply that. 6 times 5 is going to equal 30. And then I am going to write my special word. Hold on. Of square, because this is area, and then use my unit centimeters. So the area is 30 square centimeters. Okay, let's go to number 6. Number 6 says, what is the area of a square with sides that are 8 centimeters long? Show your work. Okay, this is that special circumstance, but before we look at that, we're going to circle our 8 centimeters long, and we're gonna underline the question. The question says, what is the area of the square? That's what I'm trying to figure out. Now, remember that special circumstance I spoke to you about with our squares all having the same side? That's why they give us one number. It's the same thing here. So we're gonna go ahead and draw our square, and I'm gonna try to draw those sides as equal as possible. It may not be as equal as I can get it, but I'm gonna try. So now the length is gonna be 8 centimeters. And remember, all sides are gonna be the same size with the square, so that means our width is also gonna be 8 centimeters. And now I'm gonna figure out how many squares I can fit inside of this square. So let's go ahead and write our equation, which is length times width equals area. So the length here is 8 centimeters times the width of 8 centimeters. And then if I multiply my 8 times my 8, that gives me an answer of 64. And because this is area, we use our special word of square. And our unit is centimeters. So the area is 64 square centimeters. All right, that's it for this one. So I am going to have to erase this, and then we're going to go ahead and do number 7 through 9. Okay, this is 7 through 9. 7 says, what is the area of rectangle B? Show your work. So this is rectangle B, it's labeled B, and they want to know what is the area. So they already put our numbers on our rectangle for us. We just go ahead and put our labels, because you know I like to label. So the length here is going to be 4 units, and the width is going to be 8 units. So now that I have labeled, all I have to do is go ahead and follow that formula, or let's say the equation we're using, which was length times width equals area. So let's go ahead and do that. The length is 4 units. I'm going to write 4 units, and you make sure you write your units, times the width, which is 8 units. And when I go ahead and multiply that, 4 times 8 is going to give me an answer of 32. And because this is area, we're going to use our special word of squares, because we're trying to figure out how many squares I can fit inside of this particular rectangle. And it just so happened I can fit 32 squares inside of that one. So 32 square, and then the units. That would be our area. Okay, let's go ahead and go to number, let me erase this off of here. We're gonna go to number 8. So number 8 says, Lena draws a square with an area that is greater than the area of rectangle B. Now we really have to start thinking about this. It says, what are 2 possible side lengths of Lena's square? So they want us to go back and look at B. I can move this for you.
That's good.
You sure? Okay. So I can go back and look at rectangle B. So they want me to have an area that is going to be greater. First of all, let's look at, I'm sorry. All right. First of all, let's look at this word greater than, or this phrase greater than. We have to be able to understand what they're asking us so that we know what to do. Greater than means bigger. It's going to be larger, more than. So if the area, they want it to be more than the area of rectangle B. Well, the area for rectangle B was 32 square units. So whatever we do, we have to pick numbers that'll give us an answer that is going to be bigger or greater than or more than 32 square units. So let's go ahead and do that. It said, what are 2 possible side lengths, Lena square? What are 2 possible side lengths of Lena square? Okay, so let's draw this out. Let's try and draw this thing out, guys, because Miss Newman loves a drawing, It's so much easier for us to see and understand when we have a drawing. All right, so if I look at this, we can change we can only change, well, we can change both of the numbers. If you like, we can pick two new numbers, or if you like, we can change just one of our numbers. And I think Ms. Newman is going to go with that second option of changing just one of those numbers. Ms. Newman is she's talking so fast, her brain can't keep up, or her brain is thinking so fast, I can't keep up with my talking. So let's go ahead and change one of those numbers. I think I'm going to go ahead and leave the 8 units the same. So I'm not going to change that one. So I'm going to put 8 units here. But the other number that I'm going to change is going to be the 4 units. Now, if I want something that is going to be greater than, will I choose a number that is going to be smaller than 4? No, because that means it's going to give me a less than answer of something less than 32. So that means I'm going to pick a number that is going to be higher or greater than 4. So you can pick any number higher or greater than 4. You can pick 5, you can pick 6, 7, 8, 9, 10, whatever number you want to pick. Ms. Newman is going to go one number up, and she's going to pick 5. So I'm going to change that 4 units to 5 units. And now I'm going to go ahead and solve this just to make sure that I get an area that is going to be greater than the area of 32 square units. So let's write our equation. It's going to be 8 units times 5 units. Okay, 8 times 5 is going to give me an answer of 40. And because this is area, we use our special word of square and then units. So Ms. Newman got an answer of 40 square units. Is Ms. Newman 40 greater than 32? Yes, it is. So that means we did it correctly. So let's go back and reread our question to make sure we have answered our question. It says, what are 2 possible side lengths of Lena's square? Explain. So we did the explanation when we did our drawing, and now we're going to finish it off with the word sentence that is going to answer this question. What are 2 possible side lengths of Lena's square? We would say 2 possible side lengths of Lena's square is, okay, Ms. Newman is thinking. She caught something and she's thinking. But I'm going to finish writing this. Is 8 units and 5 units. Okay. So Ms. Newman wrote that as 2 possible side lengths. But, you know, Ms. Newman was looking at that, and it caught her attention when she was looking at that because it said something that I really didn't notice at first, but I was noticing it as I'm writing my question, that word square. Square, remember, that's that special shape where all the sides are the same thing. So, did Ms. Newman follow directions when she did that? No. Ms. Newman made a boo-boo. She went ahead and she didn't read everything that she was supposed to read, so she made a mistake. She was supposed to draw something or choose numbers that would be similar to square, and squares all have the same numbers. So instead of using a 5, Ms. Newman should have used an 8 because it should have been all the same thing. So this should be changed. Instead of a 5, this should be an 8, and this should look more like a square. So what I'm gonna do, you know what, Miss Newman is not even gonna erase it. I'm gonna do another one on the side. So I'm gonna do another one, and I'm gonna try to make it look like a square. Okay, so this will be 8 units. The length and the width is gonna be 8 units as well. And now we're trying to figure out what that area could be. So this is what that would look like. And now we would do an equation that would be 8 units. Let me do a different color, guys, so you'll know which one goes for what. So this will be 8 units times 8 units. And when we multiply our 8 times our 8, that gives us an answer of 64. And because this is area, we use our special word, which is square, and then our units. So now Ms. Newman has followed directions. Ms. Newman was just going along and not paying attention, but it happens. Hey, I'm sorry, I apologize. So this is supposed to be 64 square units because they asked us for Lena's square. They kind of tricked us a little bit because they started off with a rectangle and then our rectangle turned into a square. But it's okay. It's okay. So now we have 2 new possible side lengths. So we can also say that 2 possible side lengths would be our 8 units and 8 units. Try to shorten it so I have enough space. 8 units and 8 units. All right. So that goes with this square. And Ms. Newman, just let me erase this because I want to make sure I keep the colors all the same with the numbers. So you know that these numbers go for this square here. I'll do one better. Ms. Newman will just redraw this square in blue. So you know the blue square goes with the blue words and the red square goes with the red words and numbers. I don't want to confuse anybody. So Ms. Newman is going to do her best again to draw that square as equal as she possibly can. So this will be 8 units. And then this will be 8 units. That way all the colors go together. There we go. So this square goes with this, and then the red square goes with the red information. Great, now we're back on track. All right, let's go ahead and go to number 9. I'm gonna erase this little writing right here. All right, so number 9 says, Pablo draws rectangle P. Okay, so this is rectangle P, and it says, he says the area is greater than 50 square units. Okay, so Pablo now is telling us that the rectangle he has an area that is greater than, okay, greater than, remember we just did one with greater than, and greater than means it's going to be more than 50 square units. So that means whatever numbers we pick, it has to give us an area that is going to be more than 50 square units. So let's think about this. So it says, what could the unknown side length be? So, I have to think to myself, this is where our skip counting could come into handy. If they gave us 6 units already, they gave us that number, I can do a skip count by 6 and see where I would get a number that would be greater than 50. So let's do our skip count by 6. Here we go. And Ms. Newman actually has her posters up here. I don't know if you can see this one, but this is our skip count by 6. We start off with 6, 12, 18, 24, 30. That's our 5th finger. 36, 42, 48, 54. When I got to 54, is 54 greater than 50? Yes, it is. It's a bigger number. So that's my ninth finger. So I can use the number 9, or I can go even one more and go to 60. Is 60 greater than 50? Yes, it's a bigger number. So I can use my 10, I'm on my 10th finger, so that means I can use 10. So we can use either number 9 or number 10. Ms. Newman is gonna go with number 9. So I'm gonna put 9 units here because I know that would give me that number. So it says, what could the unknown silent be? We can say the unknown silent could be 9 units because 6 times 9 equals 54. And 54 is greater than 50. All right, guys. And that was the last problem for our homework. I hope you understood everything Ms. Newman was trying to explain. If you have any questions or comments, make sure you send them to me either through you can drop it in the comments on the YouTube page, or you can send it through PBIS, or because now I am posting homework videos in Google Classroom, you can send it to me through Google Classroom as well, and I will be more than happy to answer any question you have. But that is it for today. We do have homework on tomorrow. I know it's Friday. Ms. Newman hates giving homework on a Friday, but it's just the way our lesson fell. So we do have homework on Friday. Let me double check. Let me see. We have homework on Friday. And let's see. So we have homework on Friday.
I'm not sure I understand.
And then we don't have homework on Monday because Monday is review day, and then we have our next quiz on Tuesday. So I will see you guys on Friday for tomorrow's homework, and then I won't see you guys again until on Wednesday. So that is it for today. Have a great rest of your day. Bye.